We are now, yes, we are now in module 6 of mathematics course. So in this module is we'll study quadratic equation. This module introduces second degree equations. So quadratic equations are simply second degree equations that are in standard form. You see equations like ax squared plus bx plus c equals to 0. Where a is not equal to 0, that means it is a quadratic equation. So quadratics generate parabolas. When you plot the graph, it generates parabolas, not straight line, and they have two distinct real roots, one repeated root or no real root. So this module covers methods of solving quadratic equation, factorization method, completing the square method, quadratic formula, and even graphical techniques. So we'll look at it in detail. And we'll also look at the application of quadratic equation so that we see that mathematics goes beyond just mere formulas and numbers. So let's look at key concepts in it. In quadratic equation, we usually talk about vertex and axis, talk about roots and discriminant, also talk about opening direction. It is good for you to note the difference between them. For instance, vertex and axis. The vertex is a parabola's maximum or minimum. The axis of symmetry is x equal to minus b over 2a. Dividing the curve into mirror halves. While root and discriminant, you have to know the discriminant d is b squared minus 4ac. So it determines the root. That's why it's called a discriminant. It determines the root nature. If d is greater than 0, there will be two real roots. But if d is equal to 0, one repeated real root, and if d is less than 0, there will be two complex roots. So that is why it's called a discriminant. Now, we have our opening direction. If a is greater than 0, note that the parabola opens upward, meaning minimum. But if a is less than 0, it opens downward, meaning maximum. Now let's go. So looking at how to solve using factorization method. If a product equals 0, at least one factor is 0. That is what it means. For instance, if we have x minus 2 and x plus 7 in bracket equal to 0, it means x minus 2 is equal to 0 and x plus 7 is equal to 0. If that stands, that implies that x will be equal to 2 and x will be equal to 7. Now x will be equal to 2 because the minus 2 will move to the other side and the sign will change to positive. Or in other words, when you add 2 to both sides, at the end of the day, x will become 2. While in x plus 7 equals to 0, when you subtract 7 from both sides, at the end of the day, x becomes minus 7. So you can apply factorization to quadratics to split into linear factors. Then use the zero product principle to find roots. But note that if there are no factors, if they are not factorizable, they are ones that are not factorizable, meaning if there are no linear factors, you will not be able to factorize them. Alright, you can also make use of quadratic formula. Quadratic formula is x equal to minus b plus or negative square root of b squared minus 4ac all over 2a. That is quadratic formula. Minus b plus or negative square root of b squared minus 4ac all over 2a. So this formula gives exact roots for any quadratic equation. You can use this to solve quadratic equations that have factors or don't have factors. You can use it to solve virtually all quadratic equations. So that is why it's called quadratic formula. Now, for instance, if we consider 3x squared minus 5x minus 3 equals to 0. How do you determine your a, b, c? All these are in the quadratic formula, so you have to know what they represent in each question. For instance, you divide your equation into 3, a, b, c. For a is 3, b is the center one, that is the coefficient of x, which is minus 5, and c is the constant, which is minus 3. So if you impute it into that formula, at the end of the day, you will calculate it to have minus 0.47, x as 2.14, or minus 0.47 in 2 decimal places. Don't forget that I said from the beginning that in quadratic equation there will always be two roots, either two similar roots or dissimilar roots. Now, by factorization, let's solve this equation by factorization method. X squared plus 2x equals to 35. You can rearrange to bring the factor backwards. When you rearrange, you have x squared plus 2x minus 35 equals to 0. If a is 1, b is 2, and c is minus 35, the AC will be minus 35, and look for two factors of minus 35 that add up to 2. So what are the two factors that of minus 35? You have minus 5 and 7, because minus 5 times 7 will give you minus 35. So let's see if it will give us 2. So minus 5 plus 7, at the end of the day, it will give us 2. So these are the perfect factors. So the required factors are minus 5 and 7. So when you are done with that, you split the middle term into minus 5x and 7x. This is what I mean. The plus 2x become minus 5x plus 7x. So the overall equation becomes x squared minus 5x plus 7x minus 35 equals to 0. You now divide them into two brackets. X squared minus 5x in one bracket, 7x minus 35 in the other bracket. So you now try to bring out the factors. Now x into x minus 5 plus 7 into x minus 5. You can see that the ones in bracket are similar. So you take the one outside, x plus 7, take one of the brackets, which is x minus 5, equal to 0. So don't forget, either of them can be equal to 0. So when you solve, you have x equals to 5 or x equals to minus 7. You can see that it is very easy to solve. Now, in applying completing the square method, it will involve taking half of the coefficient of x, adding it to both sides. Then you factorize the left hand side and write as bracketed expression. When you take the square root of both sides, you will now arrive at the answer. For instance, in this example showing on the screen, you can see that at the end of the day, it solves to x equals to 1.31 or minus 2.31. The full steps are in the module. So when you go through the module, you will be able to discover all the steps. They are very self-explanatory. Alright? So we have also already talked about applying quadratic formula. In this example, x squared plus 6x minus 8 equals to 0. You can see that our a is 1 because the coefficient of x squared is 1. Then the coefficient of x is 6 and the constant there is minus 8. So when you put it into the formula, the quadratic formula, you'll be able to quickly solve it. It's easy when you have formula to any mathematics. Alright? So how do you approach questions that are on quadratic equation? First, when you see a question on quadratic equation, you have to think and choose your method, then compute your discriminant, solve. After solving, you can also verify your answer. Now, what are the applications? Quadratic equation is not just about formulas and numbers. What are the applications of quadratic equation? In business, for instance, when you want to have profit functions can still be quadratic, where we have y equals to ax squared plus bx minus c. So solving or finding the vertex identifies production level and also help to maximize profit. This one applies to business, okay? Even in agriculture, it is applicable. If you want to talk about the graph of yield versus fertilizer, it often follows a parabola, so it will help you to optimize fertilizer so that you can maximize yield. So this quadratic modeling informs efficient, environmentally responsible input uses. What of in sports? Projectile motion follows quadratic principles. It follows a curve. So quadratics predict range and peak height used in biomechanics and by bodies like the IOC and NASA for motion analysis and trajectory planning. You can see that when we talk about quadratic equation, it is not just about ax squared plus bx plus c, or you talk about completing the square, or talk about quadratic formula. So it goes beyond, far beyond that, because it's applicable to life itself. So in conclusion, let's look at the conclusion. So in conclusion, you have to note that anytime you are solving quadratic equation, you should know that it goes beyond formulas. So this module is trying to relate it so that you have a conceptual understanding and also the application of quadratic equation. Thank you for listening.